For lesson 83, we are diving back into the probability world where we're looking at dependent events. Let's start with a little review. We have the question, what is the probability of getting heads when flipping a coin and rolling a 4 on the number cube? For these type of probability problems, we're starting to have more than one event taking place. Notice here we are flipping a coin and we are also rolling the number cube. So it goes back to the idea, the number of events I have is the number of fractions that I want to set up for this. The first fraction will represent the probability of getting that head, and the second fraction is going to represent the number cube. So let's begin with flipping that coin. What's the probability of getting heads when flipping a coin? Well, obviously 1/2. And now we want to set up our second fraction. What's the probability of rolling a 4 on the number cube? Well, there's only one 4 on the number die, but there are 6 total possible outcomes that we could get. And now we go ahead and use our multiplication rule to get the probability of 1/12. Example number 1, we have 2 8th graders and 1 7th grader that want to go on a trip, but only 2 of those students will be selected. If their names are drawn at random, we want to know what is the probability that the 2 8th graders will get to go. This problem is very similar to the sock problem that we had before. So for this particular problem, what we could do is begin by just identifying all the different combinations that we have to come up with. You know, we just need to be able to distinguish the difference between the 2 8th graders. So let's go ahead and go 8 superscript 1 to represent the first 8th grader. There's our second 8th grader, and there's our lone 7th grader that wants to go along. So if we generate our list of possible outcomes that we could get, obviously we could begin by getting both 8th graders. So 8-1 and 8-2. We could get the first 8th grader along with the 7th grader. And we can also get the other 8th grader to go along with that 7th grader. And we could make the argument, you know, what if the 7th grader was picked first and then the second 8th grader? But at the end of the day, the order in which we select these doesn't matter. Okay, as long as those 2 students are selected, they're going to be going. So as we look at this, we have 3 total outcomes that could take place. So when it comes to setting up our fraction, 3 total outcomes that we have, and the only one where we have both of the 8th graders going is that very top one, so we only have one of those. Therefore, what's the probability that both of the 8th graders will get to go? Well, it's 1/3. For example number 2, this is where we really get into the heart of the lesson in working with a dependent events problem. A bag contains 2 white and 3 blue marbles. If 2 marbles are going to be selected, we want to know what is the probability of selecting those 2 marbles, or 2 blue ones. So here off to the right we have our bag, that's the circle, and within it we have our 3 blue marbles and our 2 white marbles. And we have 2 different cases that we're looking at. The first one is we're going to look at the case where we do not, we are going to have replacement with the first one. So again, let's go back to the original idea. How many marbles are we selecting? Well, we are selecting 2 marbles. Therefore, how many fractions do we need to set up? Well, we need to set up 2. The first fraction will represent the probability of getting the first marble. The second fraction will then represent the probability of getting the second one. And we want to know the probability of getting 2 blue marbles. So let's just start with selecting the first one. We see that we have 5 marbles in the bag, and that 3 of those are blue. So the probability of getting the first marble to be blue is 3/5. Now the key here is the replacement part of it. Suppose I pick this blue marble. I've selected it, but now we're going to replace it. So now we put it back in the bag. So now that it's back in the bag, for the second selection, we still have all 5 marbles, and we still have all 3 blue ones. So from here we can go ahead and multiply and we know that the probability of getting 2 blue marbles with the replacement is going to be 9/25. Now let's go ahead and look at it if we don't replace it. Again, we're picking 2 marbles. So fraction A, fraction B. Well, the first probability of getting the first blue marble is going to be the same. We have 5 marbles in the bag, and 3 of those would happen to be blue. So let's pick that blue marble. There it is. I have selected the blue marble and it's outside the bag. But now I'm not going to replace it. We picked that blue marble, we've thrown it away, and now we can see that we have 2 blue marbles and 2 white marbles. So now when we go to create our second fraction, our numbers are going to be slightly different. For the second marble that I select, I now only have 4 marbles remaining in the bag. Also, I only have 2 blue marbles that are there. So if we deal with a problem where we don't replace the marble, our total is going to decrease by 1, and then this numerator could also change as well. So now if we go ahead and simplify, 3 times 2 is 6, 5 times 4 is 20, and we can reduce that down to 3/10. And notice the difference between our 2 answers. The probability has changed between replacing that marble after the first selection and not replacing it. Last one, example number 3. We have 4 different cards labeled A, B, C, and D that are face down on the table, and the order is going to be scrambled. As a card is turned over, it is left letter side up. So we want to find the following probabilities. So here's our cards, A, B, C, and D. We don't know what they are. You know, they're face down. But we want to know what's the probability of turning over an A. Well, this one's fairly simple. We have 4 total cards to select from, and only one of them has the letter A on it. Therefore, 1/4. But now let's take a look at B. Suppose we want the probability of turning over A, and then on the second turn we select B. Well, again, let's go back to the idea. How many cards are we selecting? Well, we are selecting 2 of them. Let's first find the probability of selecting A. Well, there's 4 total cards, and only one of those has the A on it. But now that we have selected A is no longer a member to be selected from when we go to pick the second one. So how many total do we have? We now have 3 to choose from, and only one of those have the B on it. Multiply across, therefore the probability of turning over A and then turning over B for the second card is going to be 1/12. Lastly, we want to turn over A, then we want to turn over B, and then we want to turn over C. So again, how many cards are we selecting? We are selecting 3 of them. So 3 fractions. What's the probability of getting A? Well, 4 total, only 1A, 1/4 again. We have turned over A, so that is no longer an option to get. So we go to the second one. What's the probability of getting B? Well, we have 3 remaining cards now, and only one of those have a B on it. So there goes the B. So now for this last one, the third and final card that we select, we have 2 cards that are available to us, and again, only one of them has a C on it. Therefore, the probability of turning those cards over in order, 12 times 2, will get us 1/24. This problem number 3 is a little bit more advanced, but I wanted to show it to you in the video just because it's a good one to be able to recognize. The only problem that I want you to do is going to be practice problem E.